In this question, they say that there is a cone, right circular cone. The base radius is 15, while the height here is 36. And then the circular cone is divided into 3 parts by 2 planes, which are parallel to the base. The heights of 3 parts are equal. That means along this height, we separate it to 3 equal sections. And then we cut it by using this plane and using this plane. So if we cut it separately, there is a cone above and then a frustum in the middle, and finally we have an even bigger frustum. And this question is not difficult, but you have to pay extra attention on the wording. They're talking about the middle part, is talking about this part. So they are talking about the volume of frustum. They are not talking about the cone of these 2 parts together. So I just use a more straightforward approach, even though it may be a little bit more time consuming, to get the second part volume. This one, second part. Volume is equal to a cone, including the first and second together, and then we subtract the first part. They say the height is evenly distributed, which means that the height here is 36 divided by 3 parts, and then we take 2 from it. Each section is 12. So if we choose 2 sections together, the total height here is 24. In order to find out the base radius of this cone, maybe we separate it to 3 cones. A smallest cone, similar to our middle cone, similar to we include all 3 parts, the largest cone. Why we try to consider cone but not cone with frustum is because cone are similar to a cone here. So that's why we can make good use of the length ratio. The height here is 36, so this is 12, this is 2 section 24, we just calculate it. And then the base radius here is 15. So you find that we divide by 3, we get this one. So that's why this radius is 5. And from here, we just multiply each length by 2. So that's why this is 10. But of course, this is for your understanding only. In our actual presentation, you may let this base radius be R. So let R be the lower base radius, and then we just consider 2 similar triangles. The first one is this cross section, the second one is the larger one. If we separate them, we have 36 and also 15, similar to a middle cross section with the height 24 and R. So we know that 36 to 24 is equal to 15 to R. We can solve R is equal to 10. So after that, we can write that this is 10. Similar reason, the height here is 12, while the base radius here is 5. To find out the volume, this volume, we just apply the cone volume formula, 1/3 base area pi r squared times height. The base radius here is 10, while the height is 24. Minus 1/3 pi r squared times height. R is 5 here, and the height is 12. We get 700 pi. The unit is cm3. This is the volume of the middle part, so this is our answer. Part B, which is similar, we are asking the curved surface area of the middle part. Remember the word curved. That means we only consider the lateral surface, but we do not consider the base circle here. So If we stretch it out, it is arc like this. And obviously it's come from the curved surface area from first and 2. Curved surface area from this cone, and then subtract the curved surface area from the smallest cone. The curved surface area is pi RL by the formula. So we have R, the base radius of the cone, but we also need to find out L. In this cone, the height is 24, and then the base radius is 10, and it's formed a right angle triangle here. So the slant height by using Pythagoras theorem is square root 24 square plus 10 square. And then we get the answer equal to 26. Another slant height, again we have the height which is 12. So the slant height is square root 12 square plus 5 square. We get 13. Now we have all the information we need. Pi RL, the base radius of this cone is 10, while L, the slant height of this cone is 26. Similar calculation for another part, we have 5 and 13. Therefore, we have 195 pi. In this question, they say express in terms of pi, so these two answers are good enough to answer the question.